Okay, gotta come in for part 2. I was rudely interrupted by a phone call, and they didn't even bother to talk on the phone. That was just lame. All right, this one's not going out on YouTube, I'm just saying. So iron 3 chloride, iron 2, so that means that these have different charges. And that's a fairly important concept right there. So when we give the formula, we're going to need chlorine has a -1 charge. So that's going to be FeCl3 and FeCl2. They're both iron chlorides, but they're not the same. They're like brother and sister. Same family, but they're not the same individual. That's the best way to do it. They're siblings. Whether they get along or not, we don't care. That's not what we're worried about here. So, these are examples of Roman numerals, okay? They're Roman numerals. As we remember that there was a Roman Empire at one point in the past, okay? The stock system for naming the compounds, that's the Roman numerals. Why is it important to balance the plus and negative charges of ion in a formula? Stability. Because if you have a negative or a positive, guess what? It's not stable. It's going to look to react. That's a pretty important concept. What do we call a compound that's got no water in the molecule? It is anhydrous. Not Anheuser-Busch, anhydrous. So when we talk about naming a compound that's got water connected to it, this is where we're going to do calcium sulfate heptahydrate. So you need to be up on your Greek numerals. So questions like this, what's the chemical formula for sodium cyanide? Okay, I'll let you guys figure that one out. Okay, I'm going to keep moving. Okay, so we're done with that. And let's go and let's talk about part 2. Okay? So in looking at this, look at the following reactions. So we're looking at equations, parts of equations, balancing equations, and types of equations. Okay? Bell's going to ring in a few minutes, but I'm still going to go. It's called dedication to the peeps, yo. So 4Fe plus 3O2, and here's the arrow, gets us 2Fe2O3. Ooh, that's chemicalese. Okay? So, reactant or reactants? What's the reactant? Remember, the reactant, ladies and gentlemen, is what's going to be mixed together. You can look at it as ingredients, like you're baking something. So here we have iron and oxygen as our reactants. We have iron 3 oxide as our product. Okay? So that's what we have. Define the reactant and product. Product is anything that you end up with in a chemical equation, coefficients and subscripts. Okay? If you look at 2Fe2O3, this is your coefficient, these are your subscripts. When you balance a chemical equation, this is what you play with, the coefficient only. You do not change these. Those are fixed. They are unmovable for the purposes of balancing a chemical equation. Okay? All right. And remember the goal of balancing, any equation is to make sure you have equal numbers of the same element on both sides of that arrow. For example, if I got 2 oxygens on the reactant side, I should have 2 oxygens in the product side. If I have 4 hydrogens on one side, there should be 4 on the other. Now I can have 4 hydrogens on one side, 2 oxygens on that same side, our reactants. We should be coming out with 4 hydrogens and 2 oxygens in the product. This is the law of conservation of matter. That's kind of an important thing for us here. Okay? Why do we need the balance set? All right. Equation symbols. Guys, you should know what that means. Okay? So, S, solid. AQ, aqueous, think like solution mixed with water. G means not G-O, it's G for gas. And sometimes you'll see an arrow going up. The arrow pointing this way tells us it's going to result in, it's going to yield. Okay? The triangle above the arrow tells us we're adding heat to this. Okay? When you see an element like PT, platinum, above the arrow, it means that it's a catalyst. What does the catalyst do? It affects how fast the reaction goes, and it doesn't get used up. Okay? Now, types of reactions. We've covered that. You got 4 basic kinds. Synthesis is when you are taking atoms and putting them together, like putting Legos together to build, you know, an X-Wing fighter of the Resistance so they can blow away, you know, emo gothic loser Kylo Ren. Note, I'm not asking for bad things to happen to the actor in real life. It's just the character is such an embarrassment to villains throughout the ages. Okay? Decomposition reaction is when you're breaking down something. Like the Star Wars story. Okay, when you are breaking down, like, you take popcorn and put it in your mouth. And your saliva works on it and helps break it down. You swallow it. It's in your stomach and it also gets broken down. That's decomposition. So you're taking something that's big and breaking it into smaller pieces. Single replacement, double replacement reactions. This is where we got switcheroos, okay? So single replacement, A plus BC. So we got one piece by itself, and here we have an item. They go to Lancer-La-Palooza. And they spend the evening, and what happens at the end of the evening? You got B is alone, but A has hooked up with C. This is a single replacement reaction. So in this, how do you tell if it's single versus double? In single, you only have one element by itself in the product. I mean, in the reactants. Okay? Now, double. When you look at double, it's a bit different because now you have, and I can't work with that. So, okay, so AB plus CD. So now we have 2 compounds coming in. And what happens is they do the switcheroo. So you got CB plus AD. This is a double replacement. This is a double replacement type of reaction. Okay? And again, it's like going to Lancer-Palooza. You get 2 couples, they're items, they go in and the evening happens and they switch. And I just want to let you know that the end of the review is there because the namesake is staring at me through the window. I'm Fuzzy, and I'm here for you. Signing off.